Hi, hello, and welcome. Hi, guys. Welcome to today's Plumbers of Data Science episode, the second try of episode 100. Yesterday was quite a fiasco. I think I have all the problems ironed out, Windows updates, and so on. So, yeah. So we are going to start with the Spark Week, Spark Weeks, Spark Month. Hi Dragonfly, hi Rodney, hi Nick. So let's dive right in. One more thing, if you're new here on this channel, we do a lot of data engineering, and right now we're going to focus a bit on Spark. If you're new, hit the subscribe button to get all the updates. And if you like this and think this is great, check out my data engineering cookbook that is free on GitHub. Link is in the description. And if you want to send some bucks, some bucks in my direction, because you want to support what you like, check out my Patreon. It's always also in the link. So just a quick recap what we are looking at today. We're looking at Spark topics day one. Why is Spark so great? So just a quick overview for the absolute newbies. What's the difference between stream and batch processing? And I have found another thing about a quick comparison to MapReduce that I think fits right in there. Then Spark and AI Summit 2019. I have a few slides. I think it was from the last from last year. And Nick sent me a link to some videos. Videos. I don't want to show videos on here, so I need to first check the videos. So we're going to move this. Let me show off my new tool here. If it works. So this thing here, we're going to go and we're going to put this into day X, maybe 2. And then drivers and executors, we're going to do this today. Standalone, client, yarn mode, yes. Spark context, Spark streaming context, a bit. Databricks and Kubernetes, I have this ties a bit into standalone and so on. So let's get to it. Hi guys. Hi David. Hi Dylan. This is my new screen tool. I like it. One more thing I want to say here before we start. This is not a training. So this stuff is not, I don't know everything. And most of the things I'm working through as well. And we're going to work through this together. So when I'm wrong, and this is going to happen possibly a lot, guys, tell it to me, send me links, write comments to this video so we get this stuff straight, and we work together on bringing value to the community who is looking this. So don't go crazy if I'm talking wrong stuff. I might be wrong. I'm also working through this. This is a fun journey. So, okay. Back to this. So what I want to start with is why Spark. And the thing is, if you look at data, you have stream and you have batch processing, and I think I need to organize this a bit different here. Let me just, okay. Usually the difference is what you can have is you have this big chunk of data, and you want to analyze a slice here. You want to take this slice and you want to do some analytics and then come to some conclusion. And depending on the size of this chunk here, this is going to be problematic. And here comes these distributed processing tools, and they are basically parallelizing your analytics. So they are not doing one query and through basically one stream and get the data and analyze it. They are doing a lot of stuff in parallel. So this then you're starting this and you're taking a chunk, you're analyzing it, you come to a conclusion. This is batch processing. So this is one use case for these tools like Spark. Then the other use case is you have a lot of small data. And this data is basically flying in from one side, and you want to do some analytics. And then you basically store it or you visualize it. And when you basically get streams and you analyze them, we could build a thing around here. This is stream processing. So now here's the question that always comes up is, but Andreas, we're doing this for years. We used some stuff like MapReduce for this, and here comes the problem why Spark is so great. So what Spark is doing, Spark is working in memory, and not like Dragonfly says, can you go over that again, please? I'm not 100% sure. So you're having a big chunk of like batch processing. You're having a big chunk of data, or a big amount of data. You're taking a huge chunk. This can be terabytes, and you want to analyze it in analytics in one. Let me put here one arrow. So in one process, and come to a conclusion. This is batch processing. If you have a lot of small data that is flying in very, very fast, and you're doing recurring analytics on that, that is called stream processing. So you're processing the data when it comes up, and this is then going into some storage or something. And so the problem was we used to do this with tools like MapReduce that were not in memory capable or in memory based. And what you had is like this. I hope it's a bit clearer on your end. It's a bit fuzzy here on my end. The thing was this. You had HDFS. Oops. And then you had MapReduce. So you would take data, you would analyze it. Then you need to store it again. And then you need to analyze it. And then you would go back, take it from storage, analyze it, and go forward, because you have no in-memory capability. You just, after each step, you need to store the data again, and then at some point you come to a conclusion. And this is where, I don't know, this is, I'm moving the wrong mouse here. This is from Jefferson Mercado, software engineer. Oh, okay, now I need to align this again. Okay, so here's the thing. When you're in the ecosystem of Spark, you have your storage, and this is in a Hadoop environment. You have your HDFS, your real storage. You load it into let's say RAM, and then you process it, and then the result is going back into RAM, and then you analyze it, and then you're going to go back, go forth, and at some point you come to some storage. This is the Cassandra sign here. I would do for continuation to be basically like the top one here, and this is HDFS again. They say 10 times faster here. It doesn't matter. It depends on absolutely the use case. I would say 10 times is a bit of an understatement. So this is basically how this comes together. And here's the if you don't look at the at machine learning and so on, the basic of Spark, which makes it so great, is parallel processing, and is that you don't have so much I/O on the hard drives. You have RAM. You need a lot of RAM. Of course, you need a lot of RAM, and then you can do very, very good analytics. Okay. HDFS is like hard drive. HDFS is the Hadoop file system, and this is basically a distributed file system based on hard drives, based on SSDs. And yeah, one thing. Hey Sebastian, one question here was, I would from DevDude, I would like to collaborate to help you with the documentation for this if you're willing to guide. Yeah, the goal is to bring this to the cookbook. So if you want to help here, take a screenshot, and we're going to put it in the cookbook. Yeah. So this is the first overview. Can I take a screenshot of this? Okay. This is the first thing that is important. Now let's go back to let's go back to the slides. So we have this. Then the next thing is the understanding, how does this work? Drivers and executors. I mentioned this. So Spark AI Summit, we're going to. I don't want to start OBS. Go away. This you can see in this slide. This is from the documentation of Spark, and the idea here, the idea behind all this is this: you have your worker nodes, and the worker nodes, these are basically these are servers. Server N, and this is server 1. And the idea is you have the driver, and the driver is basically in a program. You can see this as a main function in Java, in Scala. It's literally the main thing of your program. And there you're loading, or you're making statements how you load the data and how you want to process the data. And what the driver and what the Spark context is doing is, on the worker node you have executors, and these depend also on how much resources you have on the worker nodes. And the worker nodes, they start the tasks who are getting planned by the driver, basically by the context, or based on how you process the data in the context. So basically this thing here spawns all the tasks and is responsible for the parallel processing, for the, let's say, for the management of this whole thing. And this is more or less, if you're running, you can run Spark in some modes. If you're running in client mode, this client mode is on your PC. If you're running in something like a cluster mode, where we come in a second, this is then running also on one of these workers. So this thing here makes it a bit clearer again. Here. So here we have this the driver, and the driver has basically all the information what is going to happen here in this code. You have a filter, you have maps, and then you have actions like count. And once until a action is triggered, this is not executed. And once an action is executed, then all the code before, like the reading and so on, is getting executed. And then the driver creates the Spark context. And what that does is it schedules basically, or it creates from the RDDs, from the data sets, or from the RDDs, you can say it's like variables that you're transferring. We are going to come and look at RDDs more in the future. Basically, the idea here is a RDD, a resilient distributed data set, is distributed can be distributed over the network or over the workers. And once it's created, you cannot change it. And the idea here is, with, for instance, a map and so on, and joins, you can basically create new RDDs. You can create from the RDD1 and from the RDD2, you create a new one. This would be 3 and this would be 4. And how is this stuff processed? And here comes the funny thing, how this is done. How this is processed, the Spark context is basically creating the tasks. And these tasks, as I understand it, and as I have seen it, these tasks then get spawned on the worker nodes. Let's do this like this. And so you're getting the parallel processing, and yeah, it's quite simple. And because you have the cluster manager who's doing the resource allocation, because these things, these worker nodes, they have limited amount of storage, of disk, not storage, of storage, of RAM, of CPU time, or CPUs, and so this needs to be managed. Yeah, and so this is basically the one of the main things how Spark works. And what makes Spark so good is also this concept of RDDs. Once they're created, you cannot change them, and this is why they are so good in usable for distributed processing. You create one, and then you can take slices of an RDD and distribute it. Basically what they are doing is they are taking this RDD1 and they are creating 1, 2, and 3, and basically slices or partitions, how they are called. And then you can distribute these partitions again to the workers in the tasks. So yeah, it's immutable, of course. I tend always to use simple language as much as possible, because I personally hate it when people are talking in in this high level talks. I cannot do this. This it's on me. So this is basically how this works. And if I would remember what DHG means, let me just check this. Data analytics graph, I think it's called. How this looks in a program, you can visualize this on your in your Spark environment. You can then see the stages, and you can see what is happening in the stages. So like here, you create a text, or you read a text file. Direct analytics graph. You create a text file, and then you map it. You make a flat map, which is we're going to come to this, I think, in day 2. And then you're going to do map. This is a bit different, and then you're using it. This is like something like a word count. You read the stuff from the file, and then what you're ending up with is in this RDD you have the file you have the rows. With a flat map, you are basically in every row you are splitting the rows. So you're getting a huge basically these all end up here, split it into words, and with map then you can map the words together. So you have word 1, word this is hard to explain here. You can basically then give every word a number, like 1. So you have let's do this like this. You have a word this. So this comes this is twice in there, and that is only once, and then you can reduce it, and basically in the reducer you count these, and then what you would end up with is something like this is 2 and that is 1. So it's very simple. This is a super simple example, and you can basically see the stages. This stuff gets complicated. This gets super complicated, or you can make this super complicated. Like, I think here's another example. So here's a more interesting example. You have some input. Can I make this bigger? This a bit. You have an input. You can parallelize this, map. Group by stuff, and then on this slide here you can then take the things and you can split it, or basically copy it, or you can join stuff together. So basically you can check how this all works together. And from the Spark UI you can see the DHU visualization. And this stuff is all created on the driver with the Spark context. Yeah. So this is more or less this is the essence how Spark works and how Spark plans the data or works with the data. And let's leave it with that. One thing that we have for day one also, standalone client yarn mode. Where was the programming guides? Somewhere here in the documentation they had this also explained. Just want to show this to you. Why don't I have this as a no, I think it was deploying over. Okay, this here was it. So you have a few management cluster manager types, and the idea here is you have what people are who are on a Hadoop environment often use is the yarn, yet another resource manager, basically the resource management for the Hadoop cluster, because it's good to run the Spark workers on top of the data nodes, so you don't have to transmit all the data through the network or over the network throughout the nodes, and so it makes sense. And then you're using yarn for that. Then you can create different yarn queues for different processes, like for Spark or for MapReduce and so on. Another thing is standalone, which is very often used. Just today I learned on LinkedIn that the Databricks solution that uses standalone management. I also used standalone before. I think that absolutely makes sense. Because Spark is not coupled to Hadoop. You can have a lot of inputs to Spark from Kafka, from S3, and so on and so on. And so you don't need to have Hadoop. And if you don't have Hadoop, you don't need yarn. You can use standalone resource manager. Works perfect. Works great. And Mesos, I have to admit, I'm not I'm not familiar with Mesos. And then you have Kubernetes as well. Kubernetes more or less a Dockerized or a Docker management tool. What do they say here in the documentation? Security, Kubernetes cluster. Let me just check if there is more. Yeah, so I'm not 100% sure. What I think how it works is your client does Spark submit here, and then your Kubernetes cluster is then spawning the Docker nodes who are basically the executors who are working and who are processing the tasks. So this is a container, and this one. And this one, and this one, and they are all managed by Kubernetes. And you have, so here this thing does also CPU, network, and so on, and storage. Yeah. So this is more or less the whole thing. You have a few options how you can schedule the schedule your or manage your Spark cluster, and yeah, I have used Yarn and Standalone before. Perfectly fine. If you're on Hadoop, use Yarn. Just use Yarn. What do I have more? I wanted to show you one more thing. I was looking into Databricks and the Spark Summit. What I have seen is, and as a quick side note, how people are using this, or using the data lake and using basically Spark right now, is you have your big data lake and your enterprise data warehouses, and then wasn't there a or maybe I'm wrong. I thought they had an example here how the Spark is running there. Okay, let's do this slide on another day. I don't want to get bogged down here. Yeah, guys. So I would say this is more or less the stuff that we should look into for today. Is a streaming or a context. We have found out, or let's go from the top. We have found out that Spark is great because it's in memory and you can do stream and batch processing with it. We know what the driver is and what executors are, and basically that the driver is managing the how the data is processed, and it's getting split, and the executors are there to execute tasks that are basically managed by the driver. Standalone client, Yarn mode, resource management. So this we talked about. Spark context. This is it's more or less we've been looking at this slide. Where was that? At this slide, how this works. How basically the tasks are getting created. Where was the slide? Yeah. So I think this is more or less day one. Your questions. And then we are going to already finish the stream, but first your questions, because I want to keep these daily streams short and on point, depending on how many questions you have and how many ideas you have, and what we should look into as well. So guys, let me just check some chats here. Does it also show record counts? That was, I think, for the example with okay. Running on each task, running on each. Silence is always. Everybody sits there. Yeah. All right, Andreas. All right. Yeah. Was it interesting? Dragonfly says, let's not overlook the idea that Spark doesn't do well with small data. I mean, Spark is a tool for distributed processing, and so it's implied that it works great with big amounts of data. I'm not 100% sure, Dragonfly, what aspect you mean. But usually when you do batch processing, for instance, your data should not be in the kilobytes or something. This is this would not make any sense, because then the management overhead and the time overhead for distributing the partitions to the cluster and so on, that I think would not really make sense. Regarding the stream processing, I would say this works with small messages. It's good. Yeah. Yeah, Nixus is right. If you can keep all your data on a single node, use Python, Scala, for God's sake. Yeah. This and this is a great point, and this is what people should understand. And I have emphasized this multiple times. Let's emphasize this one more time. These are tools for processing of huge amounts of data or fast amounts of data, fast data. This is not something that you build for cheap on a single node. If you run out of performance on smaller systems, then you use something like this. These are not cheap technologies. These are not cheap tools. The tools, Spark, for instance, this is open source, and you can run it without any question on your system, basically for free. The problem is the whole infrastructure, the management, and so on. These are expensive tools, and these are expensive ways of processing data, and so you need to think about, does that make sense for my case today? If not today, tomorrow or day after tomorrow. So yeah, this is it's people need to understand this. Nick says, I want to know difference between Yarn and Mesos performance with Spark. I can Google this quickly. Spark, Yarn versus Mesos. I don't think this is a real performance. I don't think this is more a performance problem, because these should be more like these are resource management systems. So let me just this is an example for this. I cannot use this. This is for Hadoop. Yeah, maybe one of you has a link to something interesting. Chat's going quite big, quite fast. We are saving the tough questions for later days. No, Sebastian, don't save the question for later days. What you can do is, if you really have tough questions, put them in the comments of this video, so I can extract them, and they don't fly by, and we can work on this, and I can try to prepare the answers to the questions for the next stream, or ask around if somebody knows this. Yeah, that's basically preparation. I don't know what I'm talking about. Spark says Spark is 100 times faster than Hadoop. And Databricks version of Spark is 30-40% faster. So yes and no. Spark is 100 times faster than Hadoop. This basically says nothing. I'm guessing you want to say is Spark is 100 times faster than MapReduce. That's what I'm guessing that you're trying to say here. I don't know if the Databricks version is faster, than is 30-40% faster like a standard version. I'd like to see some tests about this. It's also a community version of Databricks. Yeah. If you have some stuff, please put the URL, please put the links in here or in the comments of this post so we can yeah. So as I understand it, the people are very, very in love with Databricks. I don't know. I'm guessing Databricks is one of the big committers of Spark, and it's available on cloud platforms like AWS and Google Cloud. Yeah, I don't really know a lot about Databricks, so it would be interesting to learn more about this if some of you really have insight into Databricks. Okay. Okay. The problem here is, guys, like Dragonfly, if you ask questions unrelated to this now, is this stuff then it really gets messy. So questions like these, it would be good to basically put in the chat. Data modeling, in Spark, I'm not 100% sure what on what level you mean data modeling. Yeah. Guys, oh man, now we're coming to the detailed questions. Yeah. This stuff is getting org and Parquet. How was that? One of them was from Cloudera. Which one was from Cloudera? And which one was from Hortonworks? Because if you're on a Cloudera distribution, didn't we previously also look at this? Let me just check. Yeah, both org and Parquet are supported in Hortonworks, but what was the difference here? The exact difference. I mean, not. Yeah, we have been looking at this slide here, or at this site. Let me just bring it up. We looked at this previously. I think I can remember. Org file structure, index, row data, stripe footer. Okay. Here you have the columns. Yeah, okay. What is the difference here? Parquet, org, schema, compression, splittability, most compatible platforms. Parquet, Spark. As you can see, org is more Hive, Presto, Impala, Drill. Row or column, both are column. Read or write, both are more for reads than for writes. Yeah, because they are more column oriented. This is also something to understand. If you're more column oriented, then it's good for reads, because you have only you only need a row key and then you get all the columns. It's very, very simple, like a CSV file or like an Excel sheet. If you're a row oriented row-oriented file, you can read very fast, but the writes you can write very fast, but the reads are not that fast, because you need to go over so many rows, and you need to create good row keys and so on. Yeah, Databricks provides a managed cluster service and a notebook to write your code. Yeah, this is big. I also like this. And we have on a day something, we said we want to run a Docker instance here with Spark and with Jupyter notebooks. I'm guessing this is more or less the same thing, and they are just they just modified it. Nick as well. Great, but I have Jupyter Zeppelin notebooks already. Do I need Databricks? And I don't know if I would love to speak with a Databricks expert. And so if you know a Databricks expert who I mean, not a marketing guy, you know what I mean. Yeah, maybe Deb. I don't know if you're an expert here. We can have a chat and maybe make a stream about this. There says, please use Parquet, because if you create Databricks Delta tables, its underlying format is Parquet. Delta tables support transactional statements like merge and updates. Interesting. Okay, and same notebook but extra features. That's what I meant. So these guys are also only cooking with water, and Databricks, I'm guessing they are reusing stuff and they are building stuff on top of it, but it's in the basic stuff is like Jupyter notebooks or something. Yeah, Azure Databricks. This tip would work. Okay. Just didn't you ask before where to contact me? I have seen that you have written me. Oops. That you have written me on LinkedIn. I just hadn't time to answer. Let's. Where was you? Yeah. Let's chat on LinkedIn. Yeah, quickly, you guys are talking about Delta stuff. What I have seen is this slide here, and this is an older slide, December 11, 2017, where they basically introduced Databricks Delta. I don't know how good this stuff is. They basically said a Hadoop data lake good is the scale, inexpensive storage, open formats like Parquet or Org, and the promise of machine learning and real-time streaming. Yeah. The bad is data is inconsistent. Yes, and unreliable for analytics. I'm not 100% sure what this means. Lack of schema, of course, it's a big data store, and poor performance. Not really. If you combine it with Spark, not really. And so they basically what they say, the typical data lake, and I have to agree, this is more or less a typical solution. You have your Hadoop data lake here, and there you have all they're coming all the records in, and you're trying to store it, some in a more or less messy way, and then you're pushing it out into some enterprise data warehouse, for instance, for alerting, reports, incident responses. So ETL. The problem with enterprise data warehouses is always you don't have indefinite storage. You have only 2 weeks. These stuff is hard to scale. That's just it. Proprietary formats, no predictions, no machine learning, because they're warehouses. This advantages of this architecture, they say: poor agility in responding to new threats. Okay. And scale limitation, no historical data. I'm guessing on the enterprise data warehouse side. And 6 months between 6 months and 20 people to build. This is I would not sign this. 6 months, 20 people to build. It depends on where you're running this and how you're building this. So it's complicated, especially if you not only run a data lake, if you're making these connections here. This is always in a bigger company, always troubling, because these are basically shielded, and you have to somehow get access to these warehouses. Yeah, and what they say. How can I do this? No, it's gone. Where's it gone? What they have say the next generation data platform, and this is all very, very marketing, unified data management system, scale of a data lake, the reliability and performance of data warehouse, and low latency of streaming. Yeah. So they're talking about Databricks Delta here. Databricks Delta. I don't know if any of you guys already have some experience with this. Yeah. Okay, what are you guys saying? Yes, Databricks just open source Delta Lake, says Sebastian. This is interesting. Okay. The good of data lakes, massive scale on AWS. Okay. Open formats. Well, we already had this. Real-time streaming. Yeah, you more or less have this with Hadoop. Pristine data. This is very important. Transactional also. Transactions in a normal big data environment, especially in a Hadoop environment, this is not possible. Fast queries. Okay, I don't know. These two also don't know. Okay, so yeah. Can I move this? No. Okay, doesn't matter. Massive scale, reliability. Yeah. Okay. Let's not get too far into this. So it's interesting to see, but it's all very, very high level for me right now. Yeah, it should be more mature. Let's wait a couple of months, says Nick. I don't know. This is a year old or 1.5 years old. I don't know. Different says, what I understand, executing SQL in data lake gives bad performance. So why delta? What they say is you get performance of data warehouse querying, but on data lake. The thing is, it's not 100% the case. If you're running, what you can do, for instance, let's just quickly go to this thing here. Let's make another page. What you can do is, if you're on something like a Hadoop system, you have your data in HDFS, or you have your data in HBase. If you want to have a NoSQL storage, let's say NoSQL. What am I writing? SQL DB. And you can do SQL queries with Hive. SQL queries with Hive. And the idea is, how can you get this? You can, in between the processing, this can be MapReduce. You can also do this in Spark, and then the access is quite fast. So you can basically use Spark to access or to load data from these types of systems, or from is that possible also from Kafka? I don't know. And then use it in a Hive storage and query it with SQL from your Tableau. This is absolutely possible, and this also has some very, very fast processing, because it's using Spark. What are you guys saying? No, this is for today. This is the Q&A. I would like to. We're already an hour in. I would like to keep the content of each day. I want to prepare this and bring this as condensed as possible over here, and then we're going to start and talk about this, because this should not, and I don't want this to be a training or a course or a presentation. I want to go over this stuff offline, and then I'm going to show you what I have found and what I think, and then we're going to start talking about this stuff. And so basically in half an hour or something, we get over the stuff that I have prepared, and then we're going to talk about more things and get into Q&A. Yeah. Yeah. So the move is from the move from HDFS to something to the cloud. This is, we're going to see this as something like that. It says here he's working with Azure. I'm guessing you have Azure Blob Storage and you can process the data from there. Yeah, and stuff. I'm not that familiar with Azure, but yeah, I'm thinking this is all possible. Yeah. Okay. Databricks file store. Interesting. Yeah, guys. If you have any more cool links or stuff, please send it to me, and we're going to talk through them on the next stream, and we're going to add everything to the cookbook, because the Spark section in the data engineering cookbook is quite small, and we should expand on this and put this stuff we are learning here into there. And it's free. You can make pull requests, change stuff, make pull requests. Yeah, David, please contact me offline. Interesting. Databricks file store is like HDFS. Okay, guys. So for tomorrow, what are we going to do tomorrow? Tomorrow we are going to, first what I'm going to do is I'm going to take this Spark AI Summit. I'm going to take this in the beginning of tomorrow. So what's new and what have we missed? We already a bit talked about this. I want to keep I'm going to put this here into additional ideas. We have talked a bit about today about Databricks. See the Q&A section. And tomorrow we're going to look into Spark AI Summit. Quick, this just the essence. And then we're going to look into Docker Jupyter install or running Jupyter and Docker instance of Spark, and a simple project. I'm sorry guys, can't see my screen. So basically Spark context, Spark streaming, we looked into this today. Had a Q&A also about Databricks, and then tomorrow we're going to look into Spark AI Summit. Just a few slides. Install a Docker container with Jupyter notebooks, and then we're going to do a simple Jupyter notebook, and then I'm going to try to find some slides how the management, maybe we do this way around. Yeah, we're going to do it this way. We look into slides from last Spark Summit. What's new? What's interesting? Then we look at the basics. How does an RDD work? How does a data frame and a data set work? And then we're going to look into how can you monitor this stuff that we have seen today with DAG and so on. How do you monitor streaming jobs? And then we're going to install a Docker container with Spark and Jupyter, and then we're going to do a simple, let's say a word count example or something that I might be finding. This would be the goal for me to prepare for tomorrow. Let's see how far I come, and then again, if you have any more questions, by the way, hit the like button on this one. If you have any more questions, put them in the comment section, or not in the chat here, in the comment section of the video, and then we are seeing each other tomorrow. David says, please also use Databricks. We could also run a Databricks install. Databricks. Maybe that can send me, can sell me Databricks until tomorrow. Okay, guys. Yeah. Thanks for being here. Thanks for so much feedback and talks. and great comments, very, very interesting Q&A section. For me, the Q&A is more interesting than just displaying the stuff that I have seen. The interaction is, this is what makes these streams so great, and this is why I'm reluctant to create any trainings or some sort of this. It's boring talking to yourself. Okay, guys. I'm going to end it here. It's already almost midnight in Germany. See you tomorrow. And then tomorrow with day 2. Have a great day, a great evening, or a morning. I think some guys are already on the morning. Bye-bye.